Good day, everyone. Today we will study about absolute value of numbers, or MELT 3. I am your teacher, Ma'am Juliet H. Casada. Together, let's discover the wonderful world of mathematics. Before we start, I have some health tips and friendly reminders for you. Always wash your hands, wear your mask, keep your distance, and eat your greens, because health is wealth. The terminal objective of this session is represent the absolute value of a number on a number line as the distance of a number from 0. The enabling objectives are the following. 1. Define absolute value. 2. Determine the absolute value of a given number. And 3. Simplify expressions involving absolute values. Let's have a quick review of your lesson when you were in grade 6. I want you to write the letter of your answer on a piece of paper. Are you ready? Let's start! Question number 1. What do we call this figure? Is it A. Line, B. Infinity line, C. Number line, or D. Line segment? The correct answer is letter C. Number line. For an obvious reason that this figure is composed of the numbers and a line. One characteristic of a line is that it goes on forever on both directions. It has two arrowheads. That means it can be extended in these two directions up to infinity, just like the numbers. They goes on forever. You get it? Good. Question number 2. Which are the whole numbers? So using the same figure with this number line, again, which are the whole numbers? A. -1, 0, 1. B. -1, -2, -3, and so on. C. 1, 2, 3, 4, 5, and so on. Or D. 0, 1, 2, 3, 4, 5, and so on. And the correct answer is letter D. Whole number starts from 0 and the numbers 1, 2, 3, 4, 5 up to infinity. So you know that the numbers does not end at 5 here, since we know that in a number line, having its arrowheads on both directions, it goes on up to infinity. Okay? So, again, the whole numbers are made up of 0, 1, 2, 3, 4, 5, and so on. Because when we talk about the numbers 1, 2, 3, 4, 5, not including the 0, this means that these are the set of counting numbers. Because we start counting from 1, right? So, we call them as counting numbers, or sometimes they also referred as natural numbers, and also they are called as positive integers. Do you remember them? Good. Question number 3. On the number line, the numbers on the left side of 0 is called as blank. So these are the numbers on the left side of 0. What do we call them? Is it A. Counting numbers, B. Negative integers, C. Positive integers, or D. Whole numbers? And the correct answer is letter B. Negative integers. Yes, because we read them as -1, -2, -3, -4, -5, and the pattern, you know that this goes on up to the negative infinity. And they are the opposite of the positive integers, which are found on the right side of 0. So these negative integers are used also in denoting instances like death, loss, direction that goes south, and the direction going to the west, and all the directions that goes to the left or downward. So these may be represented by the negative integers. Do you remember them now? Good work. Fourth question. What do we call the set of numbers that we see on the number line? So here is the figure, the illustration. It is already labeled. Is it A. Counting numbers, B. Integers, C. Natural numbers, or D. Whole numbers? The correct answer is B. Integers. Yes, the integers are made up of the positive, the 0, and the negative numbers. 0, of course, is neither negative nor positive. By the way, the positive numbers may not contain the positive signs anymore because we know that positive numbers are also called as counting numbers or natural numbers. Okay? So the positive signs may not be written anymore. But in the negative integers, it's very important to denote or write the signs before them. Okay? So it's the integers. Do you remember them now? Good. Last question. Which of the following is not a true statement? Is it A, 0 is greater than any positive integers? B, negative integers are less than positive integers? C, negative 1 is the greatest negative integer? Or D, 0 is greater than any negative integers? The correct answer is A. 0 is greater than any positive integer is the false statement. This is not true because 0 actually is less than any positive integer. You know that 0 is smaller than 1, 2, 3, 4, 5, any counting numbers, right? So, and the other statements are true. Negative 1 is the greatest negative integer. This is a true statement because in negative integers, as the number goes bigger, the value gets smaller. So since this is the smaller number, it has the greatest value. Okay? And in the statement D, 0 is greater than any negative integers. Yes, actually all the numbers, if you are referring to any number and all the numbers to its left are smaller than it. So if the reference is 0, of course you know that all the negative numbers on the left side of 0 are smaller than it. So it goes on, actually it applies to any number. So if you refer to negative 2, all the numbers on its left are smaller than it. Okay? So for statement B, negative integers are smaller or lesser than positive integers. Of course, the value of negative integers are smaller than the positive ones because the negative integers are found on the left side. So all the numbers on the left of any given number is smaller than it. So that's how you compare or determine the value of the integers on the number line. So I hope your mind were able to remember these things that you have learned when you were in elementary. Let's now have the discussion or the lesson proper. But I want you to listen very well and take down notes in order for you to learn a lot. Let's start. Let's take a look at this illustration or picture. What information can you get from this? Yes, this shows the location of Cynthia and Tom's house with reference to the school. So the school here is our point of origin. Okay, let's get some more information from this picture. So how far is Cynthia's house from the school? So as you can see, Cynthia's house is located here with the coordinate of -3. Okay, so -3 is its coordinate. So when we say how far, the question here is how far, it pertains to the distance of Cynthia's house from the origin, the school. So the distance pertains to the space, amount of space in between the 2 points. So the 2 points here are the school and Cynthia's house. So we are getting the distance, so therefore we have to use this vertical bar to denote that we are getting the distance. But since there is no negative distance, and we don't regard the direction in getting the distance, therefore it is not appropriate to use -3 kilometers. Okay, so how do we get the distance? We just simply count from this point to that point, from the point where the house of Cynthia is located to the point where the school is located. So we count in any direction actually. Since it disregards the direction, we start from Cynthia's house. That's 1, 2, 3 to the school. And if we start counting from the school to Cynthia's house, that's 1, 2, 3. So it disregards the direction. So we know that from Cynthia's house to the school, it's 3 kilometers. In either way we count, it will just result to 3 kilometers. So that's how we are going to denote the distance of Cynthia's house, 3 kilometers. We know that it is the distance of Cynthia's house. Now, what's the function of the negative sign here? This pertains to the direction now. So if you want to know the exact location of Cynthia's house, that is 3 kilometers west of the school. Okay, so west here pertains to the negative sign, so it denotes the direction. But since we are just asked to find the distance, so our final answer would be simply 3 kilometers. Are you following? Good. How about Tom's house? How far is Tom's house from the school? So, as you can see, it has a coordinate of 3 or positive 3. So, if we get its distance, so we have to use the two vertical bars. Do you think it's appropriate to use positive 3 kilometers? Since it's not a negative distance, right? Actually, no. It's still not appropriate to use the positive 3 kilometers to denote the distance because the positive 3 pertains to the direction again. So, now let's count again the distance. Okay, let's determine the distance from point of origin, which is the school, to the point where Tom's house is located. So let's count in either way, in either direction. Let's start counting from the school. That's 1, 2, 3. And if we count from Tom's house to the school, that's 1, 2, 3. So again, in either direction, you will get 3 kilometers. That's the distance in kilometers. That's the distance of Tom's house from the school, 3 kilometers. And if you want to know the exact location again, the positive sign earlier here denotes the direction. So where is it located? Yes, eastward of the school. It's 3 kilometers east from the school. That's the exact location of Tom's house. But again, our concern here is simply the distance. So we just get the final answer as 3 kilometers. That's the distance of Tom's house from the school. Now, is there any difference between the distance of Tom's house and Cynthia's house from the school? Let's take a look at it again. We know that Cynthia's house is located at the left side of the school, while Tom's house is located at the right side of the school. And Cynthia's house has a coordinate of -3, and Tom's house has a coordinate of +3. But when we determined the distance earlier, we just obtained 3 kilometers here. That's the distance of Cynthia's house, while Tom's house also has a distance of 3 kilometers from the school. So, it's clear that there is no difference between the distances of the two houses. They are both 3 kilometers away from the school. The only difference is the direction, right? But the distances are the same. Get it? Good work. Now, what's the point here? The distance disregards the direction. There is no negative distance. These are the things that you have to remember. First, there is no negative distance. The distance of -3 and +3 from 0 is the same. So when you write that in symbol, the distance of -3 is written like this with 2 bars enclosing it. And the distance of +3 from 0 is written like this with 2 bars surrounding it. And you know that it is 3 units. Both of them are 3 units away from 0. So this one is what we call as absolute value. Okay, the distance of any number from 0 is called as absolute value. So actually, we read this expression correctly as this, the absolute value of -3. So that's how we read it. And when we say absolute value, we get the distance of that number from 0. And this one is read as the absolute value of +3. So the distance of +3 from 0 is 3, which is the same as the distance of -3 from 0. Do you follow? Let's now dig deeper about the absolute value by having more examples. So we know that this is the distance of a number from 0 on the number line. So we will be using a number line here to illustrate the absolute value. Let's have this. This expression is to be read as the absolute value of +9. Okay, so we are getting the distance of the +9 from 0. So we know that +9 is on the right side. And if we're going to count from 9 to 0, that would be 1, 2, 3, 4, 5, 6, 7, and up to 9 units. So we know that positive 9 is 9 units away from 0, even if we start counting from 0 up to the number 9, the positive 9, of course, we will have and we will know that it is 9 units away from 0. So the absolute value of positive 9 is simply 9. That's the distance from 0. So how about this? We read this as the absolute value of positive 7. So again, positive 7 is located here at the right side of 0. And if we count from 7 to 0, that's 1, 2, 3, 4, 5, 6, 7. And if we start counting from 0, that's 1, 2, 3, 4, 5, 6, 7 units away from 0. So the absolute value of positive 7 therefore is simply 7. Okay. Now, let's take a look at this. This time it's the opposite of the positive 9. So the absolute value of negative 9 is, you know that negative 9 is on the left side of 0. Counting from negative 9, we will get 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So starting from 0, that's 1, 2, 3, 4, 5, 6, 7, and 9 units. Negative 9 is very clear. It's very clear that negative 9 is also 9 units away from 0. It's just the same distance as the positive 9. Okay, so since we have discussed earlier that in getting the distance, it disregards the direction. Okay, so we know that positive 9 and negative 9 has the same distance from 0. They are just both 9. Are you following? So what about the absolute value of negative 7? So I guess you already know the pattern. Yes, since they are both 7 and they are just opposites, we know already, even without counting on our number line, we know already that the absolute value of negative 7 is the same as the absolute value of the positive 7. We know that this is also 7 units away from 0. Do you get it? Good. How about this? The absolute value of 0. How far is 0 from 0? Of course, it's still 0. It is 0 units away from 0 from itself. Okay, so 0 is the absolute value of 0. Now, I want you to focus on this special case. So what makes this different from the first examples? Yes, it has a negative sign outside the absolute value sign. The first 5 doesn't have a sign before the absolute value sign, but here, in our last example, we have a negative sign here. So we know that the absolute value of negative 10, the distance of negative 10 from 0 is 10 units, right? So again, we read this as the negative absolute value of negative 10. Okay, so there is a negative sign outside. You read it first. Again, this is the negative absolute value of negative 10. So the absolute value of negative 10 inside, you know that it is already 10. So the distance of negative 10 from 0 is 10 units. But since there is a negative sign outside, you simply have to copy it to affix the negative sign on the final answer. So our final answer is negative 10. Are you following? Very good. Let's have some more examples. So let's start with number 1. This is the absolute value of positive 13. You know that positive 13 is on the right side of 0 and it is 13 units away from it. Okay, 13 is the answer. For number 2, this is the negative absolute value of positive 54. Okay, again, the negative absolute value of positive 54. So you know that the absolute value of 54 is 54. But this is a special case. There is a negative sign outside, so you just have to copy the negative sign. So what will be the answer? Yes, it's negative 54. Number 3. We read this as the absolute value of positive 7, minus the absolute value of positive 2. So there are two expressions here with an operation in between, the subtraction symbol. So what do you have to do with this? Simplify the absolute values first, then you perform the operation. Okay, so simplifying the absolute value of 7 and the absolute value of positive 2, positive 7, positive 2, that would give us 7 and 2. And now we copy the minus sign, the subtraction symbol. So again, the absolute value of positive 7 is 7, and the absolute value of positive 2 is 2. And then we copy the operation, the subtraction symbol. Now, these are just the natural numbers, counting numbers. We perform now the operation, or they are whole numbers also. So, we will have, in the final answer, when we subtract 7 by 2, we will have 5. Okay? Do you follow? And for number 4, first, we read this as the absolute value of negative 5 plus the absolute value of negative 3. So, simplify first the absolute value of negative 5. That would give us 5. And the absolute value of negative 3 is 3. So, therefore, simplifying further this, 5 plus 3 is equivalent to 8. That's the final answer. Are you following? Very good. For the last number, this is the absolute value of positive 9 times the absolute value of negative 2. It's just the same. We simplify the absolute value of 9, that's 9, and the absolute value of negative 2, that's 2. And then we just copy the operation in between, which is multiplication. We then now multiply 9 by 2, and we will get 18 as our final answer. Do you follow? Nice work. If not, please go back to the previous examples. Now, I want you to try the following on your own. You get a piece of paper and answer them. And pause this video while you are answering these problems. Good luck! Okay, it's time to check. Number 1, that's the absolute value of positive 25. So, it is simply 25. Number 2, the absolute value of negative 30 plus the absolute value of positive 4 will give us 30 plus 4, and then simplifying it further will give us 34 in the final answer. For number 3, the absolute value of positive 7 minus the absolute value of negative 3 will give us 7 minus 3. So we have to simplify the absolute value of 7 first. That's 7. And the absolute value of negative 3, which is 3. And then we copy the operation, the subtraction symbol. And then subtracting them further, it will give us 4 as the final answer. In number 4, we have the absolute value of the negative absolute value of negative 9. So here, we just have to affix the negative sign outside. So this is a special case. Okay? We just have to simply copy the negative sign in the final answer. So it will give us negative 9. And finally, the absolute value of positive 8 will be simply, for number 5, the absolute value of positive 80 will be simply equivalent to 80. So here are the answers. How many of them did you get correctly? If 5, very good. If 4, good job. If 3, nice work. And if 2 and 1, of course you have to practice some more. Go back to the previous examples to be able to understand the lesson well. So, that's it. Congratulations. Now let's try this another one situation. James and Daniel were at Enrique's house. James rode his bicycle 3 kilometers west of Enrique's house, and Daniel rode his bicycle 4 kilometers east of Enrique's house. Who traveled greater distance from Enrique's house, Daniel or James? So I want you to draw an illustration on this situation using a number line. A simple illustration will do. So you may pause this video again to write your answer and also solve the problem. Have fun! So it's time to check. Your work should look a little like this. Okay, so like this of a boy riding on a bicycle. It's okay if you only have the labels and the number line. Okay, so anyways, Enrique's house would be the origin, the reference point. It should be on the 0. Okay, Enrique's house is the origin. So the ones who traveled 3 kilometers west of Enrique's house. So west means it goes on the left side, west. So 3 kilometers. So on the number line, the coordinate is -3. The ones who traveled 3 kilometers west should be located on the number line with -3 as its coordinate. So this is James. Okay, and of course the ones who traveled 4 kilometers is Daniel. So with the +4 on the number line, on the right side of the number line. So this is Daniel. Okay, analyzing the distance that they traveled, James has a coordinate of -3, so we know that the distance is 3 kilometers. And Daniel's coordinate is +4, which means he traveled 4 kilometers. And comparing these two, we know that 4 is greater than 3. Therefore, the ones who traveled the greater distance is, yes, Daniel. Daniel traveled a greater distance than James. That's the answer to our problem here. Do you get it also? Very good. It's quiz time. So I want you to get a piece of paper and a pen. I want you to write true or false. Are you ready? Let's start. Question number 1. The absolute value of a number pertains to the distance of a number from 1. Is it true or false? And the correct answer is false, because the absolute value is the distance of a number from 0, not 1, but from 0. Did you get it right? Good. Question number 2. The negative absolute value of -80 is equivalent to 80. Again, the negative absolute value of -80 is equivalent to 80. True or false? The correct answer is false, because if you're going to simplify this is equivalent to -80. You just have to copy the negative sign outside the absolute value sign. You have to affix the negative sign in the final answer. Okay? So, if you get this right, good job. Question number 3. When simplified, the absolute value of -5 plus the absolute value of -3 is equivalent to 8. Again, when simplified, the absolute value of -5 plus the absolute value of -3 is equivalent to 8. True or false? The correct answer is true. Yes, because we have to simplify first these expressions on the number line, on the absolute value signs. So the absolute value of -5 is 5. The absolute value of -3 is 3. And getting the operation, which is addition, and performing it, the final answer is 8. It's a true statement. Good job. Let's now summarize our discussion. We have learned that absolute value pertains to the distance of a number from 0 on the number line. We also learned that in symbols, we use the 2 vertical bars to denote the absolute value of a number. Also, there is no negative distance. And finally, there is a special case that if there is a negative sign outside the absolute value sign, you have to get the absolute value of the number first and then copy the negative sign. So, I hope you take note of this and you learned a lot from our discussion. Good day, everyone! Today, we will study about addition and subtraction of integers, or MELD number 4. I am your teacher, Ma'am Juliet H. Casata, and together, let's discover the wonderful world of mathematics. For this session, our terminal objective is performs addition and subtraction of integers using models or chips. The enabling objectives are the following. 1. Add and subtract integers using chips. to add and subtract integers using the rule and apply the accumulated knowledge in solving real-life problems. Are you ready? Let's start! Let's have a quick review of our past lesson, but there is a 5-second timer for each question. Let's start! Choose the letter of your answer and write it on a piece of paper. First question. The distance of a number from 0 is called as A. Absolute value, B. Fraction, C. Integers, or D. Variable. And the correct answer is A. Absolute value. Question number 2. What is the absolute value of negative 7? Is it A. Negative 7, B. 7, C. 0, or D. 10? And the answer is B. 7. Did you get it right? Good work. Third question. Which of the following will give an answer of 4? Is it A. The absolute value of negative 7 plus the absolute value of 4? B. The absolute value of positive 7 minus the absolute value of 4? C. The absolute value of 0 plus the absolute value of negative 4? Or D. The absolute value of 5 times the absolute value of negative 1? The correct answer is letter C. The absolute value of 0 plus the absolute value of negative 4 will give us 4. Did you get all 3? Good job! Let's now have the discussion or the lesson proper. But I want you to listen very well and take down notes in order for you to learn a lot. Let's start!
Is it going up or down? We have here an elevator. So, in a situation like this given problem, J rode an elevator on the 29th floor. It goes down 14 floors and up 7 floors. What floor is he on now? So, in this given problem, we are asked to know which floor is he or J now, knowing that it goes down and up in that elevator. Going to represent it as integer, this up is known to be positive and this down is negative. If you can still remember in our video for session number 4, knowing this integer that represents up or down in the given illustration there. Now, we are talking about integers, and in this problem, you will learn how to use addition. Okay, let's start with the discussion. These are the things that you have to remember. Rules for adding integers. First, to add integers with the same sign, add their absolute values and use the common sign in the answer. So I have here the given same signs. Positive plus positive, that is in color yellow, that will give you a positive value. And if you have negative number plus a certain negative number, this results to a negative number also. That is if you have the same sign in addition. Now, if you are going to add integers with different signs, subtract their absolute values and use the sign of the integer with the greater absolute value in the answer. It is shown here. For the different sign, if you have here a positive number which is greater than the negative number, you have to subtract and then just copy the sign of the greater absolute value or having this greater number that you are adding. So that is positive. Another, if you have here negative, a greater value for negative plus the smaller value for positive, then you have to subtract and then just keep the sign of the bigger number. So it will become negative number. Okay, so that is what you have to remember when you are adding integers. Again, for same sign, simply add and then copy the sign. And for the different sign, you have to subtract and copy the sign of the bigger number with absolute value. Okay, so let's have when using chips or counters. Now let's look at models for adding and subtracting integers. How to add integers using chips or counters? I have here positive integer, which is in color yellow, and a negative integer in color red. Given 4 plus 5. So we are modeling here addition of integers with the same sign. Let's use the chips or the counters. 4 is a positive number and 5 is also a positive number. So what we are going to do is to represent it by chips, which is in yellow color, as I have already shown to you a while ago. So I will be giving you here 4 yellow chips and 5 yellow chips. If we are going to combine these yellow chips, of course, you will just simply add all of these chips. So it is just resulting into positive 9. Since they are both positive, the answer is also a positive number. And therefore, add their absolute values and use the common sign in the answer. Okay, so that's why you have here to combine all these yellow chips and that will serve as 9. Next example for this. Given 3 plus 7. Again, they are also the same in sign, which are both positive. So I have here yellow, 3 yellow, and added to 7 yellow chips. So when you combine these chips, that will be equal to how many? So that is 10. Again, you just add their absolute value. So 3 plus 7, because they have the same sign, and then copy their sign, which is common to them, and that is positive 10. And of course, when you combine all of this, they're just having the same in color. So those are all yellow, which is 10 chips. Okay, so let's try this given. So remember that positive plus positive is just equal to a positive number, and negative plus negative is equal to a negative number. And both negative. Again, they have the same sign, but they are both negative. Let's use the red chips to represent a negative number. So I have here 4 chips plus I will add another red chips, which is 3. So I have here 3 chips. So how many chips do I have now? So I have 7 red, and that red represents negative. So I have negative 7. Just remember to add their absolute values and use the common sign in the answer that you have. So negative, and this is also negative. That's why you will use their common sign, which is negative. That is what you have to remember. Another example to this. Negative 4 plus negative 5 is just, okay, by representation again. So we have here 4 chips plus 5 red chips. So we have all in all 9 red chips, which is a negative. Okay, representation of integers, so that is negative 9. We are just adding the given integers and copying the sign that they have. So if they are both positive, the answer is positive. If they are both negative, the answer is a negative number. I hope it is clear to you. Okay, very good. The collections shown here are 0 pairs. They have a value of 0. And you're going to observe why it becomes 0. So here's the first illustration. We have 2 yellow chips and 2 red chips. So this illustrates 0 pairs. Okay, another. You have 3 yellow chips and red chips. 3 red chips. Okay, so this will also gives you a 0 pairs. Another one. You have here 4 yellow, which is a positive chips, and 4 red chips, which is a negative one. So it seems that they are opposite. If you can remember, when I discussed with you about additive inverse, it was shown there that if they have opposite signs of integers, they will give you a zero answer. So this is known as the zero pairs. The number of negative chips is just equal to the number of the positive chips. That makes it equal to zero. Okay? The following collections of counters have a value of positive 5. So what makes it positive 5? So we have here 1, 2, 3, 4, 5, 6 yellow chips or counter, and I have only one red counter or chip. So it will give you positive 5 since our positive counters are many compared to this given chip. So if you will remove these opposites, one yellow and one red counter, the remaining chips or counter is just 5 yellow. That makes it positive 5. Let's have another one. We have here 10 yellow counter or chips and 5 yellow chips. So if you have this 5 yellow and 5 red, they are opposites. They are having equal number. So we can remove this and the remaining will be the 5 yellow represented by positive 5. Okay, another one. So you have here the yellow chips, which is 9 counters, yellow counters, and you have 4 red counters. If you get an equivalent yellow here, so the remaining yellow counters or chips is just 5. That represents positive 5. Okay, and lastly, you have here, I have 8 yellow counter and I have 3 red counters or chips. So when you deduct yellow and 3 red, so the remaining is a 5 yellow counters, which is again a positive 5. Okay, so these are the collections that will give you value, which is positive 5. So just simply removing it or canceling. So those are the remaining ones. As I mentioned before, so this one gives you all the yellow chips. Okay, so those are the. Next to that is when using two colored counters to model addition, build each addend, then find the value of the collection, meaning we have the different signs. Okay, like for example, we have here 5 plus negative 3. If you have positive 5 and negative 3, let's represent it by a counter or a chips. So we have here positive, therefore you have yellow chips, and negative, and I will represent that by red chips. So when they have different signs, just simply remove the same number of chips that are opposite. You can cancel those, so we can remove these 3 pairs. So the remaining is just 2 yellow chips or counter, and therefore our answer here is positive 2, knowing that this will become zeros. Okay, so subtract their absolute value. This is the rule that you have to remember, and use the sign of the integer with the greater absolute value in the answer. So have this positive and this is negative. Why is it positive 2? Because 5 has greater absolute value. Okay, so we will just copy the sign of positive. And obviously from here, you can already get the answer. Okay, so it is up to you what you want to use. But for as long as you know already the use of these chips, just for you to be clear on the use of chips very well. So you can already identify the zero pairs when you have the opposites. Okay, so when you get that, you can easily solve for the addition of different signs. So let's have modeling addition of integers with different signs. You have here negative 1 plus 4, representing it by red, 1 counter, and 4 yellow counters. So get the 0 pairs, and the remaining is positive 3. Okay, so again, we subtract their absolute value. So 4 minus 1, we got 3. And obviously, 4 has greater absolute value. And therefore, just follow its sign. And the sign of that is positive. Therefore, it is positive 3. And it is just the same as this given counters. Okay? Have this one. Negative 8 plus 3. Let us represent this to red. 8 counters. So, 3 yellow counters. Now, you know the 0 pairs, just remove the opposites. We have here the 0 pairs, remove that. Then, we will be having 5 red counters or chips, and that is equivalent to negative 5. So just have to subtract their absolute value again. So let us subtract. This is 5 minus 3 is just, or rather 8 minus 3 is 5. And our absolute value is, the greater absolute value is 8. Therefore, what is its sign? That is negative. And I will just copy the sign in my, okay, sum, which is 5. Therefore, the answer is negative 5. So, remember this one. Positive plus negative will give you a positive answer once your positive is greater in absolute value. And if negative plus positive gives you a negative value, if your red or your negative has the greater absolute value. Okay, just take note of that. Let's have another example for this given. What if I have negative 3 plus 6? So negative 3 in red counter and positive 6 in yellow counter. So again, by application of the counters or the chips, let us have the 0 pairs. Remove it now, since that is the opposites, and the remaining will be the answer. So we have positive 3 for this given adults. Now I can say that we are just subtracting their absolute value again. So 6 minus 3, we have 3. And 6 has the bigger absolute value, so that is positive, and therefore you have positive 3. Okay, so we are just applying the ideas on what to do when adding integers. Okay, let's try this. Okay, so use 2 colored counters to model the following addition problems. So you can use a black or a red ball pen just to shade your given. So do it in your notebook. So you can use any materials that you have in with you. So let's start. These are the given. Number 1, negative 5 plus negative 2 equals to blank. Number 2, negative 3 plus 6 is equal to blank. And negative 4 plus 2 is equal to what? Just find your answer and do it in your notebook. So I will just give you 15 seconds maybe. You can just pause the video if you want to take more time. Okay? So do it now. Okay, time is up. Let's show the answer. So maybe it will also help you really understand what we are going to do. Okay, so I have here negative 5. That is represented by red counters or chips. And I have negative 2. So they are having the same in color. So you are representing same signs. Just add. The result will be negative 7. Okay, next for number 2. We have negative 3 and positive 6. So you have the 0 pairs here. These are opposites, so you can cancel this. Okay, and the remaining will be 3 yellow chips or counters, and that is positive 3. Now for number 3, we have negative 4. Therefore, it is shown here by 4 red chips or counters and 2 yellow counters. And obviously, we have to make it a 0 pairs. So we will remove that, and the remaining chips are just 2 red, and it is negative 2. Okay, very good. So I know that you got that answer, and actually you are listening maybe for this video. Okay, now I want you to try without the counters. Find the sum of the following. These are the given. -6 plus -8 for number 1. Number 2, -8 plus 10. And number 3, 7 plus -14. No need for you to use the counters or the chips. Just do it manually to get the answer. Okay, find the sum. Do it for 15 seconds. Start. Okay, time is up. Let's answer this. Okay, for number 1, -6 plus -8 having the same sign, and our answer is -14. And now for number 2, we have -8 and other is +10, different sign. You subtract, so 10 minus 8, that will give you 2. And look at the greater number, that is +10, so your sign will be +2. For number 3, you have 7 and -14. They have different sign. Just subtract 14 minus 7, that will give you 7. But then remember, what is our greater absolute value here? That is 14, which is negative. That's why your answer is -7. I hope it helps to everyone. Okay, good job. I know you got 3 points to this given. In this problem, a while ago in our first slide and the problem, going up or down. So J rode an elevator on the 29th floor. It goes down 14 floors. So if down, you are representing it by -14, correct? And up 7 floors, which is +7. What floor is he on now? Of course, we need to represent it that J is in the 29th floor. Of course, that is the +1. If you're going to add a -14 and add +7, what do you think will be the result? So simply add the first two given number or add it. So 29 plus -14, so different sign, you can subtract 29 minus 14, that will give us 15. Then copy 7. So add 15 plus 7, we have 22. And J now is on the 22nd floor. Okay? So that is our problem a while ago, and it was already answered. So J is on the 22nd floor. Okay. How to subtract integers. In this part, what we are going to do is a subtraction of integers. How to subtract integers. So remember this. The rules of subtracting integers is here. To subtract a signed number, add its opposite, or you may use this mnemonic. So what is that mnemonic that you have to remember? Keep, change, change. I will show you how to apply that. So here, it might make you confused, but later in our application, I will just teach you the clear one. So here is the rule for that. Positive minus positive, you have to change to positive. Remember, keep this first given. So keep it. That's why it is still positive. Then change, change. So if you are going to change negative, it will become positive. Okay, and change again. So this is positive, so it will become negative. Now, if you have positive minus negative, so keep, change, change. It will become now positive. Then change the operation to positive or plus. Then your negative will become positive. Okay, next. Negative minus positive. All you have to do is to copy or keep this negative. Then again, your minus will become plus and your positive will become negative. Okay, so keep change is being applied. Next, negative minus negative. So it will be changes to negative, keep it. Then your minus will become plus, change it. And your minus here, or negative rather, will become positive because you changed it. So this mnemonic is very important. Keep, change, change. Let's now, how to subtract integers using chips or counters. Let's have here an example. Negative 1 minus 4. All you have to do is to remember the mnemonic, which is keep, change, and change. Okay, so it's here. If you're going to observe this, I have from negative 1, I just keep it and make it again negative 1. Just copy. Then change your sign or your operation, which is subtraction, into addition. So from subtraction, it becomes addition. And of course, this 4 will be changed also, because our mnemonic that you have to remember is keep, change, change. So let's change the sign of this positive 4, and it will become negative 4. So that was changed into negative. Then observe it. We are now adding the opposite. Okay? So instead of subtracting, we will just add. And this is what we are going to use for the counters representation. Okay? So we have here the addition 1. You have negative 1 is represented by a red chip, or that is a counter. Plus, we have another negative. So negative 4, I have 4 red chips, red counters. Now, if you're going to combine these counters, that will result into a negative 5, which is the difference of the given integers. Okay, that's why the answer here, if you have negative 1 minus 4, this is negative 5. Okay, so that is our difference. I hope you can understand what I am discussing with you. Okay, just remember this: keep, change, change. Okay, we will continue modeling subtraction of integers. So if this one is the given 5 minus 2, remember the rule or the mnemonic rule, which is keep, change, change. So when you keep this 5, it will become positive 5, then change minus 2 plus, and then change positive 2 to negative 2. Now let us represent it or model it into counters. So when you have positive 5, that is a yellow counters. We have 5 yellow counters. And we have negative 2 as red counters. Okay? Just remove the 0 pairs, which is the opposite. So we have here opposites. And the remaining is a yellow chips, which is 3. Therefore, the answer for positive 5 plus negative 2 is just positive 3. Okay, so if you just follow these mnemonic ideas, which is keep, change, change, you will not be confused. Okay, simply copy, then change, change. Okay, that is all about subtraction of integers. I want you to remember this always. In adding integers, these are the rules. To add integers with the same sign, simply add and then copy the sign of the given numbers, which are common to them. So positive plus positive remains positive. Negative plus negative remains a negative number. Okay, just simply add. But if you have integers with different signs, get the difference between their absolute values and use the sign of the integer with greater absolute value. So if they have different sign, positive, negative, subtract. And then whatever sign of the greater absolute value, that will be our sign of the sum of our integers. So that is what you have to remember as rules for adding integers. And for integers, these are again the rules. To subtract integer With signed numbers, add its opposite, or you may use this mnemonic. Keep, change, change. Okay, so it was shown with you before, so you have to remember that. Now, I hope it will be of great use when you try this given. Okay, so try this. Use two colored counters to model the following problems. Remember that subtraction is an application of addition. Okay, so you will just simply use the addition of integers. But remember to keep, change, change. These are the given. So negative 4 minus negative 2. How are you going to make it in a two colored counters or chips? For number 2, 3 minus 5. Do it now. Time is up. Let us see. So when you are going to answer that, remember to keep, change, change. So you have negative 4 plus positive. This negative 2 will become positive 2. Then you can represent it or model it with 4 red counters. Then plus positive 2, so 2 yellow counters. Then remember the 0 pairs. Remove that. The answer now is negative 2. Yes, you get it correctly. Very good. Let's have number 2. So positive 3 minus positive 5. So keep, change, change. So you have 3 plus negative 5 representing it. So positive 3 yellow counters and negative 5 red counters. So remove it, 0 pairs again. Then the remaining is the 2 red counters. That's why it is also a negative number. Okay, so these are the answers when you use two counters or two colored counters rather. How about if we will not use this? We will simply subtract and apply the rules. Okay, that is given. Number 1, 6 minus negative 8. Number 2, negative 8 minus 10. Number 3, negative 14 minus negative 4. Your 15 seconds is given to you. Answer it now. Time is up. Okay, I know that some of you were still answering. You can pause it if you want to continue. Okay, so for our answer, for number 1, 6 plus 8, since keep, change, change, then the answer is 14. Number 2, negative 8, copy, change, minus to plus, then positive 10 will become negative 10. Therefore, the answer for number 2 is negative 18. Let's have number 3. Negative 14, copy, then change, it will become positive or plus, and negative 4 will be positive 4. So subtract this, 14 minus 4 is 10, then that answer is negative 10. Since your 14 is a greater number compared to 4. Okay, so that is it. Very good. So I know you got it correctly. Okay, good job.
Good day everyone! Today we will discuss multiplication and division of integers. I am your teacher, Ma'am Juliet H. Casada, together with Ma'am Mylen Haminal. Let's discover the wonderful world of mathematics. On this video, you will learn how to multiply and divide integers using a model or guide. Number 2, multiply and divide integers using the rule, and apply the accumulated knowledge in solving real-life problems. Let's have a quick review of our past lesson, but there is a 5-second timer for each question. Let's start. I want you to choose the letter of your answer. First question, which of the following counters would give a sum of 0? Is it A, B, C, or D? And the answer is C. Did you get it? Good. Question number 2. Which of the following will give a sum of 2? Is it A, 17 plus negative 19, B, 3 plus negative 5, C, negative 3 plus 1, or D, negative 17 plus 19? The answer is D, negative 17 plus 19. Did you get it? Nice work! Third question. What is 7 minus negative 6? Is it A, 13, B, negative 13, C, negative 1, or D, 1? Answer is A, 13. Did you get all three? Good work! Let's now have the discussion or the lesson proper. But I want you to listen very well and take down notes in order for you to learn a lot. Let's start.
Let's surf under the sea. Given this problem, while on a scuba diving expedition, Elijah finds himself 30 feet below the surface, so his elevation is negative 30 feet. If he dives to the depth 3 times as low, what will his elevation be? As you can see here, that is Elijah while he is underwater. So he's 30 feet below the surface. And in an integer, we can represent it as negative 30. And the question is, if he dives to the depth of 3 times as low, what will his elevation be? What do you think are we going to do with this given situation? Oh yes, we will be using here multiplication. And what we're going to multiply, my dear, is the negative 30 and 3, which is known as 3 times as low as this negative 30. Okay, so we will now be entering on multiplication of integers. And later you will know the answer to this given problem of Elijah. Okay, ready to this now? These are the things that you have to remember. There are rules for multiplying integers. The first one, the product of 2 integers with the same sign is positive. And it is always positive for as long as what you are multiplying has the same sign. And the other one, the product of 2 integers with different signs is negative. Okay, just remember that different signs will give you the result of a negative product. And have this illustration for you to understand well. You have here positive multiplied to another positive number will give you the product of positive. And negative times negative is equal to positive product also. So just take note that same signs will result to a positive product, but different signs will result to a negative product like this. So positive times negative is negative. Negative times positive is negative. These are the things that you have to remember as rules for multiplying integers. We multiply integers. To remember whether your answer will be positive or negative, when multiplying, we'll use Mr. Multiplication. Who is multiplication anyways? So it's here. This is the code that you have to remember about Mr. Multiplication. So it is a combination of multiplication and division. That's why it is, or he is known Mr. Multiplication. Okay, let's start with this figure of him. We have here negative, negative, the result is positive. Negative, positive is negative. And positive, negative will give you the result of negative. See? So it can be useful when you are multiplying integers. how to use Mr. Multiplication in multiplying integers. So here is Mr. Multiplication. If the given is 5 times negative 3, when multiplying two integers, what you have to do is to cover the two signs you are using. You have here positive 5 and negative 3. So you will use positive and negative. Just cover it. Then, after covering, what sign is left uncovered? So yes, that is negative. And that is the sign that you're going to use in your answer. That's just as simple as that. So 5 times negative 3 is equal to negative 15. Okay, we base that from the sign that is left uncovered. Okay, let's have another example. Negative 3 times positive 8. Cover again the signs that you are using. This is negative and positive. So I will cover negative and positive signs. Then what sign is left uncovered again? Okay, correct. That is negative. So that is the sign that I'm going to use for the answer or for our product. Then now we can multiply 3 times 8, that is 24. Therefore, you have negative 24 as product. Another example. If you have negative 6 times negative 2, they are both negative. Let us cover these negative signs here. So you have now, what sign is left uncovered? That is a positive sign. That is our sign for our answer. Negative 6 times negative 2 will give you the result of positive 12. Okay, just showing that they are both negative. That's why it is a positive product. I want you to practice this. You can use Mr. Multiplication or you can simply use the rules in multiplication of integers. Okay, so I have here 4 given. Please try to answer this in just 15 seconds. Again, just post it if you are going to use more time to answer. Do it now. Time is up. Let's see if your answer is correct. So for the first given, negative 10 times 3, what is your product? That is negative 30, correct. Another one, 7 times negative 5. So you have positive and negative. They have different sign. The answer is negative 35. How about negative 3 times negative 6? The answer is positive 18. Or you can simply write is that given as 18. How about this one? 8 times 9. Your answer there is 72. Good job. Okay, now I can see that you can understand our discussion. So remember this, same signs will give you positive product. Different signs will give you a negative product. Let's now solve for the problem under the sea. So again, this is while on a scuba diving expedition, Elijah finds himself 30 feet below the surface. So his elevation is negative 30 feet. If he dives to the depth 3 times as low, what will his elevation be? Okay, again, I've mentioned this already. You will just multiply negative 30 by 3. So what will be? So for the solution, we will just simply multiply it. Negative 30 times 3 will give you negative 90. And you're asked the elevation. So the depth is just negative 90 feet. Okay? So that is our answer to the given problem. Now, how to divide integers. This is the last operation of integers. Okay, how do we divide it? Let us have temperature check. The temperature increased 8 degrees Celsius over a 4-hour period. If the increase was spread equally over the 4 hours, how much did the temperature change in each hour? Okay, if this one is our temperature or thermometer rather, so how are we going to know the answer to this given problem? So how much did the temperature change in each hour. If you have 8 degrees Celsius over 4-hour period. So what do you think will be the operation that is best for us to use? Yes, we will be using here division. And what we are going to divide is an integer. Okay. Let's recall. Multiplication and thus division, and division and thus multiplication. So how are we going to show that? So I have here an illustration. If I have this rotation, just take note that if we multiply this 4 to the given value, which is 5, the result of this is 20. And if we use this product, divide it by the given 5, the result will just be 4. So they are just undoing each other. So multiplication and thus division, and division and thus multiplication. So another example here, negative 4, multiply it by 5 will give you negative 20. And if you divide negative 20 by positive 5, that will give you negative 4. Okay, what if our 5 is negative? So we can have here 4 times negative 5 will give us negative 20. And negative 20 divided by negative 5 is positive 4. So as with this one, if you multiply negative 4 by negative 5, that is positive 20. And if you divide 20 by negative 5, it is just negative 4. Therefore, multiplication and division are just inverse operations. So you can use each other for the checking. Now, these are the things to remember when dividing. So we have also the rules. These are just the same as multiplication. The quotient of two integers with the same sign is positive. And the quotient of two integers with different signs is negative. You see, they are just the same in rules. So just remember this also. For the same sign in division, they have the quotient which is positive. If they have different signs, the quotient has the sign of negative. We can use now multiplication by dividing integers. So we use this in multiplication. At the same time, we can also use Mr. Multiplication for dividing integers. Example here, negative 15 divided by negative 3. So again, remember that we have to cover the two signs that you are using. So this is negative, this is also negative. So we can cover that negatives here. Then remember that the sign left uncovered will be positive. That is the sign of our quotient. So instead of multiplying, we will divide. 15 divided by 3 is just positive 5. Okay. Let's have another example. Negative 30 divided by 5. So when you divide that, again, cover the two signs, negative and positive. So let's cover this. And what is the sign left uncovered? That is a negative. So since this is negative, you know already the answer for this given. The sign is negative. Then divide. 30 divided by 5, that will give you 6. Our quotient now is negative 6. Okay, did you get it? Good job. Let's have another one. If you have 81 divided by negative 9, so positive and negative, just cover the two signs, positive, negative. So the sign left uncovered is negative. Therefore, your answer when you divide 81 by 9 is negative 9. So this is our answer for the given. I want you to practice again answering. Maybe you can use multiplication here, or you can simply use the rules, just like what you have done in multiplication of integers. Do it for 15 seconds. Okay, time is up. Let's answer this. For the first given, negative 12 divided by 3. Okay, you can use multiplication here if you want. So negative, positive, when you cover that, the answer is negative. So your answer here is a negative 4. because 12 divided by 3 is just 4 and that is negative. Next, different sign, positive 35, negative 5 divided, so you have negative 7. For the third, given negative 42, negative 6. They are both negative, the answer will be positive. So 42 divided by 6, you have 7. Next is 64 divided by 8. They are both positive. So your answer is just positive 8. And I know that you can already get what we are showing with you. So again, this is all about division of integers. Remember that? If you have the same signs, it is either product or quotient. The answer is always positive. If you have different signs for product and quotient, you have negative sign. Okay, so that's it. This given problem a while ago about temperature check, the temperature increased 8 degrees Celsius over a 4-hour period. If the increase was spread equally over the 4 hours, how much did the temperature change in each hour? So again, we are going to divide and hit. So 8 degrees Celsius, divide it by 4. So they are both positive, therefore you have positive 2 degrees Celsius. That is, the increase in temperature is 2 degrees Celsius per hour. Okay, so I want to remember this. In multiplying and dividing integers, same signs will give you the result of positive, and different signs will give you the result which is negative. That's it for this video. This is for your references. We have Pivot or Pivot for A Learner's Materials for Grade 6 Math, Quarter 2, page 30 to 36. Grade 7 Mathematics Patterns and Practicalities by Gladys De Vera, page 48 to 68. And E-Math by Orance and Mendoza, page 44 to 74. That's it for this video. Thank you so much for your participation, listening, and trying your best to answer some of those activities. Thank you again, and God bless everyone. Take care.
Don't forget to like, subscribe, and share!